Imagine you're alone in a dark room, the kind of stillness where every sound feels magnified. You're slowly turning the dial on an old shortwave radio. The static crackles like distant thunder. You pass frequencies used by airlines, by ships, by forgotten Cold War communications, until something catches your ear. A pulse. A regular, almost artificial beat. Not strong, not clear. But there, just there. You adjust the dial. Again. The signal's still there. A ticking rhythm. In the silence. And the strange part? It's coming from a frequency that was last used by a Soviet spacecraft, launched over 60 years ago. This is not fiction. Back in the heart of the Cold War, when every move in space was both a scientific gamble and a political chess piece, the Soviet Union launched a spacecraft called Sonde 2, Sonde 2, in November of 1964. Its mission was ambitious: send a probe to fly by Mars and transmit data and photos back to Earth. This was a time when even reaching another planet with uncrewed technology was considered a miraculous feat. The Americans had Mariner missions, and the Soviets had their own: Mars probes, Venera landers, and the enigmatic Sonde series. But Sonde 2 was different. It was cutting edge for its time, boasting onboard cameras, scientific sensors, and even solar panels, an advanced array of tech hurtling through space at tens of thousands of kilometers per hour. It left Earth in a blaze of fire and steel from the Baikonur Cosmodrome, roaring into the night sky atop a Molniya rocket. At first, things looked promising. Telemetry was being received. The spacecraft was stable. Soviet engineers, their breath visible in the cold, monitored every heartbeat of the machine from their command center. They watched as Sonde 2 executed a mid-course correction burn on December 5th, an essential maneuver to ensure it reached the right flyby trajectory past Mars. It was a success. And then, silence. By mid-May of 1965, the spacecraft stopped transmitting. The Soviets tried to re-establish contact, sending commands, sweeping frequencies, even questioning their own telemetry logs. But Sonde 2 had gone dark. The official conclusion? A failure in the spacecraft's power system. The onboard batteries likely froze or failed due to a malfunctioning solar panel. A technical death in the cold void of space. A tragic, but not uncommon, fate for early interplanetary probes. But here's where the story gets strange. Decades later, in the early 2000s, amateur radio astronomers, those passionate individuals scanning the sky for fun, science, or something stranger, began reporting something odd. A faint signal, a pulsing carrier wave that matched old Soviet telemetry frequencies. Initially, most dismissed it, probably stray emissions or interference. But then came the pattern, a consistent repeating sequence, too regular to be random, static. It sounded like an old spacecraft is still trying to talk. And the frequency? It matched closely with the bands Sonde 2 once used. Now this opens a can of cosmic questions. Is it possible that Sonde 2, against all odds, survived? Could a spacecraft from 1964 still be powered, still be alive in the cold and silent reaches of interplanetary space? Even the most optimistic space engineers will tell you, no, not unless something truly strange is happening. To understand why this is so baffling, we need to look at spacecraft power systems. Sonde 2 was not nuclear-powered. It didn't carry an RTG like the Voyager probes. It depended on solar panels and chemical batteries. The batteries would have died quickly, likely within months if the panels weren't fully functional. Even if they were, degradation from micrometeorite damage, cosmic radiation, and temperature extremes should have rendered the craft completely inert by the early 1970s. Yet, the signal persisted, sporadically, quietly, mysteriously, and here's the twist. It's not just one or two people hearing this. Over the years, scattered reports have emerged from around the world, from Germany, from Argentina, from Australia, all claiming to detect similar anomalies. Some even managed to record the signals and compare them to archival Soviet frequency logs. The similarities are chilling, so what's really happening here? Could the signal be bouncing through space in ways we don't yet understand? Could it be a case of signal ghosting, a phenomenon where old transmissions refract off planetary magnetic fields or the ionosphere, and return decades later like an echo? Or if we dare to imagine, could the spacecraft be receiving power from some unknown source, a strange form of cosmic induction, or something more exotic? In the vast silence of space, sound doesn't travel, but radio waves do. And sometimes, they refuse to fade. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. In the heat of the Cold War, the race to space wasn't just about science, it was a war of ideologies, broadcast across the stars. Every launch, every failure, every silent second from a spacecraft was more than a technical issue. It was a political event. In 1964, when Zond 2 was launched, the Soviet Union and the United States were locked in a relentless struggle to prove who would own the future. And the battlefield wasn't land or sea, it was space. The Soviets had made a bold statement in 1957 by launching Sputnik, the first artificial satellite sending shockwaves through the Western world. From that moment forward, the space race was on. And by the early 1960s, the Soviets were stacking up historic firsts like poker chips. First man in space, Yuri Gagarin. First woman in space, Valentina Tereshkova. But behind the red curtain of Soviet triumphs lay an undercurrent of secrecy, misdirection, and cover-ups. That's the world Zond 2 was born into. Officially, it was a Mars flyby mission designed to transmit images of the red planet back to Earth. But unofficially, some speculate it may have had secondary objectives: military surveillance, high-frequency communications testing, even ionospheric scanning. After all, the boundaries between military and civilian space efforts in the Soviet Union were often blurred. The same rocket technology that launched interplanetary probes could just as easily deliver intercontinental warheads. Zond 2's mission was ambitious, even by today's standards. It was equipped with 2 television cameras, spectrometers, micrometeoroid detectors, and even a unique gas discharge particle detector. It also carried a magnetometer and cosmic ray sensors, designed to study the mysterious space weather between Earth and Mars. In theory, Zond 2 would pass within 1,500 kilometers of Mars, a breathtakingly close flyby. Its instruments would collect data and beam it home through a sophisticated radio system that used high-frequency bands rarely accessed at the time. Yet, the craft was plagued with problems from the start. Just 2 weeks after launch, one of its 2 solar panels failed to deploy. That was a death sentence slowly waiting to happen. With reduced power input, its batteries were strained. It limped forward, struggling to maintain communication. But in December, Zond 2 still managed to execute a flawless mid-course correction, an impressive feat that demonstrated the mission wasn't entirely lost. Soviet engineers watched with cautious hope, and then silence. No response after. May 20th, 1965. The official records, what few we have, concluded the spacecraft lost power. The failed solar panel was the most likely culprit. No scandal, no explosion, just a slow, quiet death in the vacuum of space. But here's where things get interesting. The Soviets didn't immediately announce Zond 2's failure. In fact, they stayed silent for months. When they finally released a statement, it was vague, clinical, and absent of any real detail. That silence is telling, because unlike NASA, which was largely transparent with its missions, sharing triumphs and failures alike with the world, the Soviet space program operated behind layers of classified barriers. Mission names were often changed, launch dates were sometimes misreported, and failed missions, they were buried, sometimes literally. The Soviets had even built entire launch facilities whose locations were kept hidden from the public. If Zond 2 had experienced something anomalous before its communication breakdown, it's entirely possible the public never heard about it. And this brings us back to the mystery of the persistent signal. You see, the signal reported by amateur radio, astronomers didn't match a known frequency in active use by modern satellites or spacecraft. Instead, it sat just within range of those old Soviet telemetry bands used in the 1960s. One particular frequency, 141.4 MHz, was used by several early interplanetary missions, including Zond 2. That's precisely the band where several reports claim to have picked up a repeating pulse. Their broadcast signal, very faint but very structured, a carrier wave with a heartbeat, not intelligent communication, but consistent enough to suggest it's not random. Could it be a fragment of a test signal looping back to Earth through atmospheric ducting? Possibly. But some of these detections were made by high-gain directional antennas pointed at precise locations in the sky, locations consistent with where Zond 2 might be today if it had continued on its trajectory around the Sun. And here's another wrinkle. Zond 2 was not on a Mars orbit. It was a flyby mission, meaning it didn't slow down to orbit the red planet. Instead, it slingshotted past it and continued into deep space, likely entering a solar orbit. Today, if it's still intact, it would be slowly circling the Sun, somewhere, between the orbits of Earth and Mars, a silent relic drifting for eternity. Unless it's not silent. In 2006, a retired Soviet engineer named Alexei Dobrovolsky gave an interview in which he hinted at unusual data coming from several of their early probes. He didn't name Zond 2 specifically, but he spoke of repeating echo signatures that some engineers believed might have originated from old craft that were no longer reporting. When pressed, he became evasive, then changed the subject. That same year, several amateur astronomers from the United Kingdom and Poland recorded anomalies in the 141.4 band, reporting rhythmic pulses lasting up to 90 seconds at a time. Coincidence? Maybe. Or maybe the past isn't as buried as we thought. The questions keep multiplying. Could some part of Zond 2's transmission system have survived a catastrophic power failure? Could solar radiation be intermittently triggering dormant circuitry? Or, in a far stranger twist, could another object, human-made or not, be mimicking the lost Soviet frequencies? Somewhere out there, far beyond the reach of our satellites, beyond the red haze of Mars, past the orbits of the inner planets, something may still be transmitting, a lonely signal repeating like a heartbeat across the solar system. But how? How could a spacecraft launched in 1964, without a nuclear power source, and with a failed solar panel, still whisper to us through the cold vacuum of space? To understand that, we have to look at the strange world of electromagnetic propagation in space, and the eerie phenomena that sometimes allow signals, even long-dead ones, to live on. Let's start with the basics. All spacecraft send data using radio waves, pulses of electromagnetic energy transmitted across vast distances. On Earth, our atmosphere absorbs or reflects many of these frequencies, but in space, there's nothing to stop them. That's why even now NASA can still receive data from Voyager 1, launched in 1977, more than 23 billion kilometers away. But there's a critical difference. Voyager 1 has an RTG, a radioisotope thermoelectric generator. It's still producing power, albeit a tiny trickle. Zond 2 had no such luxury. It was equipped only with solar panels and batteries, both of which should have failed decades ago. So how is a signal still being heard? One theory is signal resonance. In rare cases, electromagnetic signals can bounce between plasma fields or become trapped within a kind of radio waveguide created by overlapping magnetic fields like Earth's magnetosphere or solar plasma streams. This phenomenon has been observed in the Earth's ionosphere, where military communications sometimes ghost for minutes or even hours after transmission. In space, similar phenomena could potentially trap and echo signals over longer periods, especially if the frequency matches natural resonant modes. Another possibility is something called passive re-radiation. Imagine this. Zond 2 is no longer transmitting actively, but its antenna systems, now just dead hardware, could be acting like reflectors. If a high-intensity cosmic or solar signal hits it at the right angle, the spacecraft's structure could bounce that wave back into space. What if that reflected signal happens to mimic the frequency and structure of a Soviet telemetry band? It's like hearing an old voice, not because it's speaking, but because the room still remembers the sound. But here's where things begin to truly defy conventional explanations. In 2009, a group of radio enthusiasts from Australia's Deep Space Listening Network, an independent collective of astronomers and ex-engineers, detected a faint rhythmic signal from the vicinity of Mars' orbital path. The pulse was incredibly faint, well below the noise threshold, but digital filtering brought out a pattern. It wasn't Morse code, it wasn't binary, but it had structure, a repeating three-phase burst that matched the transmission format used by early Zond spacecraft. A carrier signal, followed by a short data burst, followed by a brief silent window. They tracked it for 22 minutes before it disappeared again. This wasn't an isolated incident. 2 years later, in 2011, researchers using the Lovell telescope in the United Kingdom picked up a nearly identical pattern, though again, just briefly. It came from the same region in space, and again, it faded. No known spacecraft or satellite was in that zone at the time. No active probes, no natural reflectors, no known signal sources. If we take these detections at face value, they suggest that either something is mimicking the transmission pattern of Zond 2, or it's Zond 2 itself, somehow still whispering. And that leads us to one of the strangest theories yet: accidental power induction. In rare cases, spacecraft drifting through certain areas of space, especially near strong solar wind currents or interplanetary magnetic fields, can experience brief spikes of electric current. It's called electrostatic charging. Usually it's dangerous. It can fry circuits and shut down systems. But what if, by complete fluke, it managed to jolt a dormant capacitor inside Zond 2, just long enough to reactivate a tiny fragment of its communication system? It sounds unlikely. It is unlikely, but not impossible. We've seen weird things happen in space before. In 1978, the Pioneer Venus orbiter experienced unexplained voltage surges every time it passed through a region near Venus's ion tail. And in 2006, NASA's Stereo spacecraft picked up a strange burst of telemetry that matched neither its own signature nor any other known probe. It was later attributed to reflected emissions, possibly even from an old Soviet satellite. So, not impossible. And then there's the idea that sends shivers down the spine of any scientist: the possibility that what's transmitting isn't Zond 2 at all. Some researchers have proposed that what we're hearing could be a form of signal mimicry, possibly from another object in orbit around the Sun, one that detected and copied Zond 2's signal for its own use. Now, before we spiral into science fiction, let's pause. There's no hard evidence for anything exotic, but radio mimicry is a real thing, used even today in electronic warfare and stealth communication systems. Could another probe, perhaps debris or even an alien artifact, be imitating the signal structure for some reason? As wild as that may sound, it's not completely without precedent. In 1967, British astronomers picked up a strange, perfectly timed radio signal from a distant source. It pulsed with such precision, some scientists seriously considered extraterrestrial origin. It was labeled LGM-1, Little Green Men. Turns out it was the first discovered pulsar, a rapidly spinning neutron star emitting beams of radiation. But for weeks, its origin was completely unknown. That kind of confusion between natural phenomena and intelligent patterns remains common even now, so if not a living spacecraft, then maybe a forgotten piece of human hardware, a misidentified echo, a naturally occurring frequency mimic, or something else entirely. We're left with a puzzle that only deepens the more you stare at it. Imagine pointing a radio telescope into the night sky and, across the hum of cosmic noise, picking up something familiar, a signal from a spacecraft launched over 60 years ago, a machine declared lost, silent, and dead, yet here it is, whispering through the void like a ghost that refuses to rest. What would that mean? Not just for space exploration, but for the stories we thought were over. Let's entertain the possibility, just for a moment, that this signal is from Zond 2, that somehow, against every law of engineering probability, its ancient hardware has persisted, that a spark, a flicker of power, a stroke of luck, or some strange environmental accident has kept a sliver of it alive, That would mean we've underestimated the durability of our creations, that even in failure they can continue, adapting, decaying, but not entirely gone. If this ghost signal is real, it challenges how we view the permanence of space missions. Right now there are dozens of spacecraft orbiting the Sun, drifting beyond the reach of their creators. Many are officially declared dead. But what if some aren't? What if they're just sleeping? A slow drift through space until a charge builds, a circuit completes, and suddenly, ping, a voice from the past reaches out. There's an eerie beauty in that thought. But then the question becomes, why now? Why this signal? Why Zonda 2? Some radio astronomers suggest we may be living in a new golden age of deep signal detection. With modern digital signal processing, we can now scan frequencies with a sensitivity that early mission controllers could only dream of. We're re-listening to the cosmos through smarter ears, and what we're finding might not be new, just overlooked. Several university-led projects are now combing through archival radio data from the past 20 years, looking for anomalies that were previously dismissed as static. And among those databases, a growing handful of researchers claim to have found more blips, low-frequency pings, structured pulses, signal ghosts that defy easy classification. Most turn out to be explainable. Some remain unresolved. But a few line up too well with the orbital paths of long-lost spacecraft. In 2021, a team at the European Space Agency released a curious internal report about an unknown transient pulse received by their deep space network. The timing, July 14th. The source, somewhere between Earth and Mars. The frequency, approximately 141.4 megahertz. The shape of the pulse, Soviet telemetry structure, mid-60s era. It wasn't labeled Zonda 2. It wasn't made public. But it fits. Now let's flip the lens. What if this isn't about Zonda 2 at all? Let's say the signal isn't from the lost Soviet spacecraft. What else could it be? One radical hypothesis is that we're picking up a form of spaceborne data drift, a kind of long-haul electromagnetic echo. Think of it like cosmic graffiti, remnants of long-forgotten transmissions bouncing endlessly between charged particles, traveling light years before looping back to Earth. It's far-fetched, but quantum physicists have long explored the concept of information retention in seemingly chaotic systems. Maybe, just maybe, space isn't as quiet as we think. Maybe it's a library of lost voices, and we're only now learning how to listen. But then there's the theory most chilling of all. What if something is trying to imitate us? This isn't entirely without precedent. In several SETI search for extraterrestrial intelligence experiments, researchers have warned of false positives, signals that appear structured and Earth-like but originate from unknown sources. Could something be using the lost Zonda 2 telemetry pattern as a kind of camouflage? Could it be mimicking human technology to slip beneath our radar? We don't know, and maybe we never will. But here's what we do know. Space is vast. It keeps secrets longer than any ocean or archive, and sometimes a whisper from the past slips through the noise. Maybe it's an old Soviet probe calling home. Maybe it's just the ghost of radio science, or maybe it's something else entirely, something watching. If Zonda 2 truly is transmitting, then its signal has become something more than just a blip. It's a time capsule, a fragment of Cold War ambition drifting silently through space, outliving the very empire that built it. And that is poetic. So the next time you gaze up at the night sky, remember this. Not everything that vanishes is gone forever. Some things leave echoes. Some machines remember their mission, and some signals just won't die. If this story stirred your imagination, if you felt the tension, the mystery, and the wonder, then help us keep these cosmic whispers alive. Like this video, share it with your fellow space-curious friends, and drop a comment. What do you think that signal really is? Could it be a technological ghost, or something even stranger? Your thoughts, your questions, your theories, they keep the mystery alive, and who knows, maybe one day one of you out there will solve it. Until then, let's keep listening. The universe might be whispering back.